sir.
Yeah.
Now we're off to the board again.
Yeah.
We have changed our location, but we still have the nature aspect to it, right? So now why don't we work a bit towards synthetic division of
Sure.
polynomials?
Yeah.
Shall we?
Yes, we will. So let's see how to do synthetic division.
Right.
So let's take an example. Let's do long division first, and then we will see how we can do similar things in synthetic division.
Mm-hmm.
Okay. So let's write down a simple equation here. Let's say we have x cubed minus 2x squared plus x minus 3. And we'll this time divide by x plus 1. So when you do this, what should come here, Gurmeet?
Now you have to take two terms, correct?
Yeah.
You have to multiply by x squared.
X squared. Perfect. The idea is to cancel out the first term.
First term.
So that's the long division concept, right? So it becomes x cubed plus
x squared.
X squared. And when you take away this, what do you get?
Minus 3.
Minus 3.
X squared.
X squared. Bring down the next term, which is plus x. Now, I should put what in the quotient?
You would put minus 3x.
Minus 3x. So it really depends on the coefficients, right?
Right.
This answer? That's the whole key. So minus 3x times this gives us
minus 3x
squared. And then minus 3x. And when you take away this, you get
4x.
Plus 4x.
Yep.
Bring down the next term, which is minus 3. And now we should put 4 in the quotient, right?
Right.
Because this is 4x. So we get 4x
plus 4.
Plus 4. Right? And the remainder will be?
Minus 7.
Minus 7.
Yes.
So what you note here is that the divisor has to be 1 degree higher than the remainder, right?
Yes,
so
that's
divisor
correct.
has a degree of 1. So the remainder could only be a constant.
Constant.
It could be 0 also.
Yeah.
So if it is a 0, then this divisor is a factor.
Right.
Correct?
Yes.
Gurmeet, could you tell me, how about the degree of the quotient? If we have a divisor with linear divisor and a cubic dividend, what should be the degree of the quotient?
3 minus 1.
Which is 2.
2. Okay.
Perfect.
I get
right?
it then.
That's
yes,
what it is.
I get it now.
So I hope you have got this process of long division, and we kind of covered a few more things which we didn't do in the previous one.
Right.
Now we'll see how to do similar thing using synthetic division, right? So we got minus 7 as our answer, right?
I've never heard of synthetic division before, sir.
Yes, kind of a new concept for many students.
Okay.
But it is like a much faster approach, right?
Yes.
So I'll show you how to do it.
Okay.
So Gurmeet, I'll show you now how to do synthetic division.
Okay,
right?
yes.
So we replace this division sign with kind of division like this, right?
Like a T-chart.
Yeah.
Okay.
Now we have to write only the coefficients of our terms.
Yes.
So the coefficient here is 1, here it is minus 2, here it is plus 1, and then we have the constant minus 3.
Right.
The divisor in some books, they take divisor as 1.
Yeah.
But I prefer to take a point which represents kind of our x-intercept.
X-intercept.
So what makes this 0?
Negative
minus 1 makes it 0, right?
Yeah.
So whatever makes it 0, we put this.
Okay.
So you have to note this. I didn't write 1, I wrote minus 1 since it makes it 0, right?
Okay.
Now I'll show you the steps to do. Draw another line here. So the first step is
you bring down your constant.
You bring down your leading coefficient, which is 1 in
1.
our case, as such. So just copy this, right?
Yeah.
1. And second step is that you have to multiply divisor with this, times it, and then place it here, right?
Yeah.
So it's like distributive property, right?
Correct.
You just multiply.
Yes.
So minus 1 times 1 gives you minus 1. And now you add these terms, right? So, oh yeah, minus 1.
Minus 1.
Yeah, minus 1.
Yes.
And now you add these terms, right?
Yes.
So you'll note in division we subtract. Here we are adding. You know why?
Is it because that was addition?
Yeah, because we change it to minus, right?
Okay.
The whole purpose here is you could take plus 1 and subtract.
Yeah.
But if we do minus 1, you add. It is a simpler process, right? So some books follow this.
Okay.
Okay. So when you add minus 1 and minus 2, what do you get?
Minus 3.
You get minus 3. Now multiply minus 1 by minus 3. That is, follow those steps. You get what?
Positive
you get
3.
positive 3. And when you add them, you get positive 4. multiply with negative 1, you get negative 4.
4.
And when you add them, you get your remainder, minus 7. Did you see that?
Yeah.
So we get exactly the same remainder, and that's the process.
Oh.
Yeah. Do you get it? How simple it is?
I get it. So now when you have this,
Yeah.
you can easily decide what your degrees will be.
Correct.
Correct.
So we have to write the quotient now. Since we are dividing cubic function with a linear function, we expect degree to be squared, quadratic.
Yes.
So these are the coefficients of your standard quadratic equation.
Oh.
So 1 is the coefficient of x squared, right? So let's
Yes.
rewrite. So we'll write down the answer as x squared. 1 is the leading coefficient. Then minus 3x plus 4, right? So
Yes.
that becomes the quotient. Do you see that?
Yes.
And the remainder is minus 7.
That's so easy.
Perfect. This is what we got.
Oh wow.
Correct?
Yes.
Could you summarize this process of synthetic division?
So
for me?
basically, synthetic division is another way that's less hectic than long division
Yes, it
for
is.
polynomials. So all you have to do is that you put your equation, rearrange this way, and it's a good way to check your solution as well because it's quick and fast. So we would write our constants here first.
Coefficients, right?
Sorry, your coefficients.
Yes.
So in this case, 1, negative 2, positive 1, negative 3.
Correct.
And here you write a value that's going to make your divisor 0.
Perfect.
So in this case, that would be negative 1. So the next step is to you work with each coefficient. So you first bring the 1 down. You have to multiply this divisor by this leading coefficient. And when you have that, you put it there.
Right.
And then you have to add negative 2 to negative 1, which is how you get negative 3.
Yeah.
Before, how we multiply negative 1 by 1, this time you multiply negative 1 by negative 3. You get the answer, you put it here. Because negative 1 times negative 3 is positive 3. And then you add. Instead of negative 2 plus negative 1, you add 1 plus 3. You get 4. Negative 1 times 4, you put it here. You add these, you get negative 7. And what you'll get is your coefficients for your quotient.
Yes.
And the degree you can decide by looking. And this would be your remainder.
Perfect. That's good.
Isn't that a less hectic way to solve a problem?
Very neat, right?
That is really neat.
So let's take another example, Gurmeen, and will you like to do it and show whether you could really do it easily or not?
Let's
right?
see.
So let's take another example and then let's work it out. Is it okay?
Yes, that's fine.
Okay. But you don't really have to do long division. Synthetic division is good enough to give you the right results.
Right.
Now this time I'm going to give you a tricky question. We are going to divide x cubed minus 1 by x plus 1. This is what we have to do.
Okay.
Correct? Now you have to do synthetic division and show me how do you divide x cubed minus 1 by x plus 1. Right?
Okay.
Here it is.
So now,
Will you like to change the seats? Come this side if it's okay?
yeah, that's totally better.
Yeah, okay, come.
Okay. So, you're a good trickster because I realized that this is missing terms.
Yeah, it is.
So another way, before you even do it,
Yeah.
if you want to rewrite this,
Yeah.
you could say x cubed. Now there's no, because you know how it's decreasing to the degree?
Yeah.
You could write your placeholders.
Yes.
So our favorite friend of all time in math is 0.
Yeah.
So 0x squared
Perfect.
plus 0x minus 1.
That has to be divided by x plus 1.
Yes.
If you don't put the placeholders, things will mess up.
Things will mess up, right?
Perfect.
So
Yeah.
now let's go to the step.
Yeah.
So we have a nice table.
Right.
Now we have to think that this is our divisor. So what's
Perfect.
going to make the divisor 0? So the answer is easy, negative 1.
Perfect.
So you put negative 1.
Yeah.
Put down your placeholders.
Perfect.
1,
Yeah.
0,
Yeah.
0,
Yeah.
and negative 1.
Perfect.
Now,
Keep it a bit high.
a bit high, right?
Yeah. Okay, that's fine. Yeah.
Okay.
That's okay.
So now you have to bring this 1 down,
Perfect.
right?
Yeah.
You have to bring this 1 down, and you have to multiply
Mm-hmm.
and put it here.
Yes.
And that would be negative 1.
Perfect. Yes, that's okay.
So 0 plus negative 1 is negative 1.
Yes.
So you put negative 1.
Yes.
You have to multiply negative 1 by negative 1 and put
Yeah.
it here, which is 1.
Perfect.
0 plus 1 is 1. Then you have to multiply negative 1 by 1, and put it here,
Yeah.
which is negative 1.
Yeah.
Negative 1 plus negative 1 is negative 2.
So the remainder is negative 2, right?
Yes.
So that means that x plus 1 is not a
It's
factor
not a factor
of
x
x
cubed
cubed minus
1.
1, right?
Yes.
That's perfect. Can you now tell me what is the quotient?
So now you have to go 1 degree lower.
Why?
So because you have to make it quadratic.
Yeah, because
Right.
this is cubic, this is linear,
This is linear.
difference is 2.
2.
Got it.
So it would be, now you have, these are really important. So
Yeah.
it would be coefficient is 1,
Yeah,
x squared.
yeah,
Here coefficient is negative 1.
yeah,
So negative x.
yeah.
And this would be plus 1.
Perfect.
With-
And remainder as
Remainder
minus 2.
as minus 2.
That's
Hip,
how
hip,
you do it.
hooray.
Good job!
You were trying to trick me, but I got you.
Yeah. Now another question. Here you got remainder as minus 2. That means x plus 1 is not a factor of x cubed minus 1. But if I replace this with negative 1, do you think we'll get remainder as 0?
We could.
We will, right?
will.
So try this as an exercise.
Okay, yes.
Try this as an exercise. If you put 1 here, 1 cubed minus 1 is 0.
Right.
So you expect remainder to be
To be 0.
So that's the next topic for us, remainder theorem.
Okay.
And we can really find the remainder even without doing
Doing
division.
division.
So that's what we are going to do now.
Okay.
Do you like it?
I like it, sir.
Okay, so I'll again put a few questions for you on synthetic division.
Okay.
And let's see if it goes
If it
well.
goes or not.
Right?
So we're wrapping up today with a really nice, lovely weather, close to being 9 o'clock. And what we have recovered today is quite some things you would not even believe. So we looked at turning points, how you don't even need to know the coefficient and degree. You can just tell it by zeros.
Perfect.
Which is a real zeros.
Yeah.
And of course, you need your graphing skills. If you really want to check your work, but you can visit back in the video and you'll see we looked at how to divide polynomials, which is long division, quite similar to how you usually divide other numbers. And then we look at if you don't want to, if you're my type of person and you don't want to go through the hectiest process ever on earth, you could do synthetic division. So sir, it was a great experience indeed. Even with nature, things could be better in my mind.
Pleasure for me.
For a longer period of time.
Thanks, Gurmeen, for
Anytime.
all this.
Thank you.
Thanks.
Take
a lot.
care.
Bye.